All right, I think we're ready to go ahead and get started. Welcome to day 9 of CSE 142, end of the third week. Just a reminder that on Wednesday I posted homework 3, so that's your homework for next week, and we're back on our normal Tuesday schedule. So that homework is going to be due Tuesday night at 11. And remember that the way things normally work is that everything you needed for homework 3, I finished on Wednesday. So anything I'm covering today is not for homework 3. We're now moving into material that will be used for homework 4. So we'll be doing that today, Monday and Wednesday of next week. Our question of the day was about your Zoom animal. I was a little surprised at how popular the gecko was and how unpopular the dog was. In any event, that was the results for your question of the day. It's been great to have those being submitted. Again, you can submit your own question of the day if you go under the Engagement Activities tab on the class webpage. People whose questions are being chosen are getting a tiny bit of credit. So if you're interested, give us a suggestion for what would be a good question to make the question of the day. Okay, so as I said, we're moving into new material that we're going to use for homework 4. Some of that material's in chapter 3, and then on Monday we'll be moving into material from chapter 4. But there's some material that I've skipped, in chapter 3 to get to the graphics. And I want to start filling that in today. So chapter 3 talks about what's known as the math class. And I wanted to show you a slide from today's slide deck that I'll be posting. This is a slide that my co-author Marty Stepp put together that gives you a summary of various math operations that are available to you through the math class. Capital M, remember the names of classes start with capital letters, so that's how you'd know that that's a name of a class. And there's a bunch of different mathematical functions. Math.abs will compute the absolute value of a number. Math.sine will compute the sine of a number. And then there's a couple of constants, math.e and math.pi are constants available to you in the math class. Now, these methods that are in the math class have an aspect to them that's going to be a major focus of what we're going to be talking about for the next few lectures. I had mentioned the idea that information flow is something we're exploring here in chapter 3, and it's going to be a major aspect of your next programming assignment. I'm not entirely sure why. A lot of us kind of wonder why, but this turns out to be something that a lot of students struggle with. So I remember when I was teaching with a tenure track faculty member when I first taught 142 here, and I told him these things we're about to talk about are going to be really hard for students. And he said, "How hard can it be?" A week later, he said, "I see, it is challenging." So in any event, I'm not trying to scare you or anything, but maybe what I'm letting you know is that if this takes a while to kind of click, then don't be surprised, because a lot of people struggle with this aspect of it. And so we're going to go slowly. We're planning for the novices. We know that some of you are going to struggle with this, so we're going to try to give you as many explanations as we can, go through lots of examples, and go through them slowly so that you can understand what's going on. Well, I'm going to start in the interactions pane, and I'm going to type something here. So I wanted to type in math.square root of 121.0. This is a case where I don't want to give this as a command, so I'm not going to put a semicolon here. I'm going to just not put anything at the end of the line. And what JGrasp does in the interactions pane when you do that is it tells you what this evaluates to. And it tells me it evaluates to 11.0. Now this square root method, you might imagine that it printed that 11.0, but it didn't. It did something different, something that we're going to be talking about today. A value was returned back from the method. And this is probably an idea that would be familiar from math, the idea of a mathematical function, f of x, where you feed in an x and you get back a y. So given some x value, you're given a y that is what that function returns for that particular x. So I gave it an x value of 121.0. It gave me back a value of 11.0. It's saying if you were graphing that function, the square root function, then when x was 121, y would be 11.0. So that's a value that's being returned. Let me show you another one. If I did ABS, which is short for absolute value, suppose I asked for the absolute value of negative 50. Absolute value, you'll remember from math class, always returns a non-negative number. So negatives gets turned into positives. So it's a way of kind of not having to deal with negatives using the absolute value function. Well, let me show you what happens when I come up here. So it's nice that in the interactions pane, you can have this little conversation with Java and just kind of ask it, evaluate this, and it'll tell you. But suppose I tried to do that same thing up here. I said math.square root of 121.0, and here I have to have the semicolons, because if it's going to be a program, Java requires that I have the semicolons in order for it to compile. And if I compile, we don't need the interactions pane for now. If I compile and run it, nothing happens. So that's not quite true. Something did happen. What happened is it called up the square root method. The method returned something, but I didn't do anything with that value that was being returned. So this is going to be a major theme, that I'm going to point out over and over again. And there's lots of analogies that we can use. One of my favorite analogies is that I think of it as ordering a pizza. So I call up the math.square root method, and I say, hey, math.square root, I want to place an order. My pizza order is for a 121.0 pizza. I call them, I tell them, that's my order, 121.0. And then what happens? They prepare it, and they send a delivery person who comes to my door, kind of knocks on my door, rings the doorbell, I've got your pizza, and I'm not doing anything with that pizza. They're returning something back to me. I ordered it. I ordered the pizza's arriving, but I'm not doing anything with that pizza. So one of the things that I could do here is I could store it in a variable. I could have a variable called root that would be of type double, and I could store this value in that variable. And I could do a similar value here, int value equals math.absolute value of the minus 50. This is a little bit like opening the door and saying to the delivery person, put it over there on the table. You're kind of saying, this thing that's coming back to me, here's where I want it to go. In the first case, I want it to go into a variable called root. In the second case, I want it to go into a variable called value. And then I could do something like saying system.out.println, root is equal to root, and system.out.println, value, I meant to have a parenthesis there, value is equal to value. So I can do something with those values, once they're stored in variables. I could compile and run this, and now you can actually see those numbers. That's what we were seeing before in the interactions pane. So in a program setting, you're going to want to do something with the values that are being returned by these methods. I often get students, I keep trying, I know the kinds of questions students ask, and there's nobody in the room to ask the questions today, so I'm going to try to anticipate a few of them. I often get students who will ask me, well, do you have to put it into a variable? And the answer is, kind of depends on what you want to do with the value that's being returned. This is a case where all I'm doing is printing them. So here, instead of using the variable root, I could have used math.square root of 121.0. And here, instead of using value, I could have said math.abs of minus 50. So in this case, the variables aren't really necessary, but it's not such a bad thing to have a couple of extra variables. I find that novices are more likely to suffer from what we call variable phobia, that you're afraid to have too many variables. And in general, I wouldn't be afraid of having too many variables. When you learn later on, you might not use quite so many variables, but while you're learning, it's not such a bad idea to tuck things away in a variable that you're going to use. Okay, so that's a general introduction to this. Well, let me say one more thing. Let me show you something that I think is worth pointing out. So there's this nice table that's in the slides. It's also in the textbook, that kind of reminds you of the different math methods. But I had mentioned to you I think it was in the last lecture, that maybe it's 2 lectures ago at the end. There's this links tab, lots of different links here. One of them is to the Java API documentation, the Application Programmer Interface. So if I go to the Java API documentation, there's all these classes that are listed here, the names of lots of different classes. There's tons of stuff in the Java class libraries. You know, Java's been around a long time. There's a lot of different things people use it for, so they've created a lot of different kinds of classes. And I can click on the math class. So this is the internal documentation for Java programmers of the math class. And it describes to you lots of different things. So you can see all those methods that were in the table, and you can see a lot of other methods as well. So, and by the way, I mean, once we introduce a class like this, once we've told you about the math class, you can now use anything from the math class. I mean, now it's fair game. That's not advanced material anymore to be using things from the math class. I want to click on this one, the cosine one, and this is giving a little more specific information than what the table gave you. It's telling you that the parameter that is being passed into the cosine method is of type double. Notice it uses that word returns the trigonometric cosine. So it's letting you know something is coming back from the method. Now, there's something different about this header. I don't know if you notice that the header is different than what we've seen before. We've been saying public static void, public static void, public static void. And I told you, starting in chapter 1, don't worry yet about it. We'll just kind of, just say public static void for all the methods that you declare. Well, this one is not public static void. So let me tell you something I hadn't told you before. The third word in that, public static, and where we've been saying void, this one says double. So let me tell you, the third word that you put there in the header of a method is the return type. Remember that Java cares about the types of things. And so you always have to tell Java about what to expect for the various types of things. And here what you're saying is that the cosine method returns a value of type double. Void, which is what we've been doing, kind of means it doesn't return anything. It's an action-oriented method that doesn't do a return. That void is meant to kind of imply nothing. It doesn't actually return something. But this is going to be something then that we'll have to understand going forward. The syntax is described in chapter 3, in this section that talks about the math class. So anyway, I wanted to point that out to you. I also wanted to, we can come back over here. I wanted to kind of get started on something new. So what I want to do, let's get rid of that. I actually wanted a little comment here. I want to start an example with you today that I'll continue into next week, where we're going to kind of be talking about dates and times. We're going to be writing some code that does some computations based on what time of the day is it, what day is it right now, the calendar day, things like that. So, and this is something where I want to show you something in the Java class libraries as well. So we can scooch down all those S classes, a lot of ST classes. There must be the SY must show up somewhere. I suppose I could do a search through all of this, but it's more fun to just look at all the different stuff. The system class. We've been using this system class. I mean, you don't really have to understand a lot about what we've been doing, but we've been saying system.out.print and system.out.println. So we can kind of click on the system class to find out a little bit more. There it's describing that inside the system class there's something called out. That's what we've been using, system.out. It's a variable, in effect, that's inside of the system class. That's where a standard output goes. I wanted to show you something different, which is current time millis. So it's a method called current time millis. It returns the current time in milliseconds. It has a kind of an odd convention, which is that it tells you how many milliseconds have elapsed since a point in time that it refers to as the epoch. The epoch is midnight of January 1st, 1970. So there's always an interesting question. It's too bad that we don't have the people in the room, because I always get interesting answers, because I ask people why 1970, and some people think it has to do with like Woodstock or something, or there's various what happened at that time. Some people think maybe that's when Java was created, but Java came 1990s, so Java came a whole lot later. Usually I get someone who figures it out or kind of knows that something that happened in the early 1970s was C and Unix. So a programming language called C and an operating system called Unix. And this is a Unix convention, a C/Unix convention, to kind of time everything relative to 1970. That's when time began, when we had the C programming language. And I keep talking about how it's a little unfortunate that languages like Java are tied to C. So we're kind of tied to some old conventions, from that older programming language. But it tells you how many milliseconds have elapsed. I don't understand. This is an older method. This was probably part of the original release of Java, and I really don't know why they called it current time millis. Why not current time milliseconds? Java usually uses really long names, and this is already a long name. It doesn't save you that much to say current time millis. So that seemed to me to be a little bit on the silly side. But in any event, let's go ahead. Let's set up a variable that I'll call millis, and we'll call the system class's method current time millis. So we'll call that method and put the value into a variable, and then we could do a little println here that millis is equal to millis. So let's see how many milliseconds have elapsed since that point in time. And we'll compile. And we get an error here, incompatible types, possible lossy conversion from long to int. Well, maybe some of you noticed this if you were paying close attention. I should have paid attention to the return type. The return type is long. This is probably the one and only time in all of 142 and 143 where you'll hear us talk about long. So don't worry too much about this. This is kind of a low-level detail for this example that you don't have to worry a lot about. But I will explain it just so that you know. At the very beginning in chapter 2, I mentioned to you that integers are stored in an exact format, but that meant they had a limited range. And so if you start getting integers that are too big, then they can't fit anymore in type int. And that's what's going on here. There have been too many milliseconds since the epoch to fit it into a simple int. And there's a variation of int known as long that is twice as much, twice as many bits available to it, so it can store much bigger numbers. But, in general, this is not going to be something you have to know about. We just need it kind of for this program. So now, what did I do? I didn't want to say int long. Maybe some of you realized I was doing the wrong thing here. I wanted to keep my variable name millis. It was the type that I wanted to change, not the variable name. I did that to see if you guys were awake. So millis is a very large number. So that's how many milliseconds have elapsed since that time before. Well, I'm interested in seeing this in a different form. So what I'm going to ask for is kind of turn that into days. How many days has that been? Milliseconds, I just don't think in terms of milliseconds. So milliseconds, if I started with that, how many milliseconds are there in a second? And normally I'd get students to tell me that there's 1,000. How many seconds are there in a minute? There's 60 of those. How many minutes in an hour? There's 60 of those. How many hours in a day? There are 24 of those. So I can kind of do a little computation there so that I can figure out what the number of days has been. So let's kind of do that, and that's a little more specific. So we'll store that and we'll run it. And that's how many days have gone by since then. All right, I want us to play with this a little more. I did want to mention one thing that I thought you might find interesting, that kind of this issue of long versus int. it has come up in interesting cases in actual real-world programs, that if you use, say, int instead of long, and it gets too big, you get what's known as integer overflow. If you're interested, Google integer overflow. You'll find there's a very nice Wikipedia page that tells you about a whole bunch of video games that have this bug and so forth. But I thought I'd mention one that came out a few years ago. The New York Times had reported on how there was a problem with Boeing's 787, and it totally is an example of where kind of understanding this int versus long becomes an issue, or understanding, computer science a little more. It says in here, each generator is linked to a control unit. Boeing found that if the 4 engine generators were left on continuously for about 8 months, a software internal counter, probably of type int, would overflow and cause the control units to enter a fail-safe mode. The FAA warned that this could result in a loss of all electrical power, regardless of whether the plane was in flight. So this is a pretty serious bug, that if this thing overflowed, that the plane could lose all of its power in the middle of flight. So that's not a good situation to be in. And I thought I would show you one more thing kind of related to that. There's a thing called nanotime that's also in the system class. This was added much later. If you wanted to, and this is not something that's since the epic. This is kind of keeping track of elapsed time. You make various calls on this nanotime. And there's a paragraph in here that I think is kind of a little funny paragraph that says, differences in successive calls that span greater than approximately 292 years will not correctly compute elapsed time due to numerical overflow. So it's kind of another example of this. This is the kind of thing, this is someone being very careful about their documentation. We take off style points if you're not making a reasonable effort on commenting your methods. And in 143, we get even more picky, that we want you to comment everything that kind of someone would need to know. This person is being amazingly careful. I almost wonder whether they kind of half laughed or kind of, when they put this in. Because what they're basically saying is, look, if you say run on your Java program and you go away and you stay away for 292 years, when you come back, the program may not be giving you the right answers for elapsed time because of your use of nanotimes. Just warning you, don't run this program for more than 292 years. Or at least if you do, don't blame us if the timing isn't correct. Anyway, there are a couple of just little examples of this issue of integer overflow. As I said, great Wikipedia page if you're interested. All right, well, so far what we've done is not all that complicated, but what I want to do is I don't want to have this in main. I don't want to have that computation in main for a couple of reasons. One is that I might want to do it more than once. I mean, this is a conversion, convert from milliseconds to days, that maybe there's a lot of programs where I'd want to convert from milliseconds to days. So maybe I want to elevate it to be something like a math class method, all those math class methods, where it's something that I could write in a generic way and use in a lot of different programs. So a public static void method, I'm going to call it to days. So the idea would be that I'm going to write a method that's going to convert milliseconds to days, and I'd put a comment in that explains that that's what it's going to do. Let's see, so let's put this here. So then the idea would be that I'm not going to do this anymore in main, that I'm going to call a method to days. That's what I want to do. And another thing I'm going to do, since I'm thinking of this in kind of a more generic way, I'm going to go ahead and change this to answer. Just use a different name. That also, it'll help, you'll see, in what I'm going to show to you in a minute. Well, this isn't going to work. A lot of you, I think, are realizing this isn't going to work. Even what we've seen already, I think this isn't going to work, right? But let's go, and the issue here is going to be that issue of information flow. In order to get this program to work right, we're going to have to figure out information flow. So let me compile, and what it tells me is that it can't find the symbol millis, that variable called millis it's not finding. So that was down here, this variable called millis. Well, why is that? It's a scoping issue. We've seen that millis is declared up here, and that's why it's, so it's visible within main. That's the scope, is that within main I can see millis, but I can't see main within here unless it had its own version of millis. Now, you might imagine that I'd move this line of code into the method, but that's not what I'm trying to do. I'm not trying to make a method that tells me the current time. I'm trying to make a more general kind of method that does a conversion. Given some milliseconds, it converts it into days. That's a different kind of thing. I don't want it to always be doing, the current milliseconds. I want it to be able to do other kinds of conversions where I give it a milliseconds and it tells me how many days that is. Well, I have some pictures that I'm going to, kind of little crude drawings that I'm going to use to try to explain a little bit about what's going on. So in main, I have a variable called millis and a variable called days. Those are local variables that are inside of main. In today's, I've declared a local variable called answer, and I need something called millis. It needs to have something called millis. It doesn't have it yet, but there needs to be something in there that would be called millis. And I've used this analogy of dorm rooms, so I kind of think of main as one dorm room, and then there's the room next door, so we kind of have this one, this one can have its own fridge, and this one can have its own fridge, right? So this one can have a variable called millis, and this one can have a variable called millis. It's just like you have a fridge in your room, the person next door has a fridge in their room. That's not crazy. That's the way it's done, is that each one can have its own thing. But what is it that we're trying to do here? The first thing that we want to do is that I need to get this value here. So there's this value called millis that main knows about, and I need to figure out how to get this value in main into this value here. I kind of show that in my second picture, which is I want the millis in main to be fed into the millis here, and we've seen how to do that. You use a parameter. So to have a value flow from one method into another method, we use a parameter. So I'm going to have when I call the today's method, I'm going to pass millis as a parameter, and then I'm going to put it here in the header. I'm going to have a parameter called millis here. Now, you may think it's odd that I didn't call it long. Again, these are kind of small details, but I'll tell you, I'm trying to write a very general purpose method here. And somebody might want to be converting, the long version of it is always in an integer form, but, what if you had, 84,567.235 milliseconds? You had a fractional part, decimal point with some digits after the decimal point, and you wanted to convert that from milliseconds into days. I want the method to be able to do that too, and that's why I made it of type double. Java's willing to do the conversion from an integer type into a double. Generally, Java's willing to do that, to take something that's of an integer type and turn it into a double, and this makes it a more general purpose method to do this. Okay, so now I've reached this point where I've figured out how to get to have values flow into this method. Let's go ahead and compile to see where we're at. The compiler gives a funny message. Variable days might not have been initialized. Java's very careful about that. It won't let you refer to a variable that you haven't initialized. Well, and it's a good reason. I didn't give a value to days. I haven't initialized it at all. So you might wonder, could I change this to days? Would that work? No, because then what that's going to do is that's going to be a thing called days over here that's not related to the days that's over here. So changing the name isn't going to work. Well, what if I what if I tried to use answer over here? That's not going to work either. If there's something called answer over here, that doesn't get it over to here. So this is the case where we need the other kind of information flow. We want to have information flow from a method out of the method. So we want to have something that flows back to the original, and for that, we're going to use a special command known as a return. I'm going to say return answer. So notice how it's in purple. Java recognizes that that's a special keyword. I'm returning the value of this variable called answer, and that means that my return type can't be void anymore. I'm going to make it double. And I have a picture for that too, which is that with the return statement, now we have our variable called answer is being returned back to main. And I want it to go into my variable called days. So let's go ahead and compile. I now have the method returning something, and it still says that days might not have been initialized. Well, let me make a copy of these 2 lines of code, because this is probably the most important, couple of lines of code or change, that we're going to make. Most important change to understand in what I'm about to do here. I'm calling the method toDays, passing in the milliseconds. It's computing an answer. It's passing it back. The pizza delivery person is at the door with the pizza, ready to deliver it to me, but I haven't said where to put the pizza. What I'm going to do is I'm going to change this to say, put the pizza into the variable called days. Put the answer that's being returned into my variable called days. And it's important to understand that this line of code is very different than these 2. So if you have to kind of pause later or kind of be thinking about it, this is a key thing to understand, is that this has the double information flow. Millis is flowing in to the method, the computation is being done, a value is being returned to us, which I store into a variable called days. So that's how I'm going to make this thing work. And if I compile and run, it now tells me that there have been 18,369.7 more or less days since the epoch. So that's good. I mean, I was looking for something like that. Let me show you one more thing. I wanted to remind you about something. So let me go to Interactions pane. This was something that I mentioned in Chapter 2 very briefly, but I said I'd remind you of it when it became important. So what if I had a double variable n that was 3.6? I can ask JGraphs, what's n? I can ask it things like, what's n times 2.75? And it'll tell me what those are. Well, suppose that I wanted to use the integer part of n, or the integer part of n times 2.75. That's going to happen. There's going to be times when we're willing to chop off the decimal point, and that's going to be in an example we're about to do. We're going to get rid of some of the number that there. So if I had a 3.6, what if I just wanted the 3 from it? And I mentioned that a way of doing that is using what's known as casting. So you put in parentheses the name of the type that you want to cast to, and then you have an expression of what it is you're trying to cast. In this case, it's n itself. I'm saying cast n into an int. You could think of it as casting it into the role of, casting it so that it can play that role. And in the range of integer, what it does is it just gets rid of the decimal point, whatever comes after the decimal point. It's just chopped off. So you'll see that casting n to an int gives me a 3. This casting operation doesn't change n. N is still 3.6. So, it's this little sub-expression that evaluates to the 3. So it doesn't change n itself. It's just within that little computation, it tells me what it is. Well, so what would happen if I cast this? Wouldn't that chop off the decimal point and give me a 9? Well, let's see. So what if I cast to int n times 2.75? So I think it's going to give me the 9. Ooh, it didn't give me the 9. Well, why didn't it give me the 9? It turns out that casting has a very high level of precedence. And so what it does is it says, I'm going to do the cast first. I'm going to cast n into an int and get a 3, and then it multiplied 3 by 2.75. We wanted it to be casting, oops, not here. We can get this back. I hit the up arrow key to get that back. We want it to be casting that little sub-expression. So first compute what n times 2.75 is, and then cast it, and that gives me my 9. I'm going to use that over here because I want to set up a couple of more variables. I want to know how many entire weeks have elapsed, since the epoch. So I'm going to take my days and divide it by 7. But this is a double, and I'm trying to get the integer number of weeks. So this is going to be a case where I need to cast to int. I'm going to need to chop off the decimal part that comes after the decimal point to just get me the integer number of days. And then I could do a system.out.println, that the weeks would be, if I thought of it in terms of weeks, it's going to be this. So how many complete weeks has that been? We can end the interactions pane. So it kind of tells me the milliseconds, it tells me how many days it's been, and that's been 2,624 complete weeks. And I can even compute how many extra days has it been not accounted for by entire weeks. And I can kind of do, not the divided by 7, but the mod by 7. Remember, the mod tells you, what's left over. So how many extra days were there that weren't part of a complete week? And so we can have kind of our extras is equal to extras. I believe that the epoch was on a Wednesday, so I think what we're going to find is that there's been one complete day from midnight Wednesday to midnight Thursday. There's been one full day, and we're in kind of the next partial day. That's why it's not telling us 2 days. As of midnight tonight, it would tell us that there have been 2 extra days. So this is kind of a first version of a little program. We're going to make it better next week, and I'll post this to the calendar today so you can run it on your own computer and get an indication of how much time has passed since that point in time. Okay, second example that I want to do today. I want us, and this will let us practice some of these math class methods. I've got kind of a starter version of this code, so I wrote some more boring code, initially. I've set up some variables, velocity, angle, and seconds. I'm setting up a drawing panel that's 600 by 600. And the idea is that I want to simulate kind of having a ball that's moving around within this drawing panel. So I want to place a ball at the exact center of this drawing panel, and I want it to be moving at a velocity of 38.4 pixels per second for 15 seconds and at an angle of 45 degrees. So for this, if someone was giving us these values, I don't want them to have to be thinking in coordinate math. I'm back to the normal Cartesian. So in the Cartesian coordinates, right, there's normally the origin, and there's kind of the x-axis going this way. So like a 45-degree angle relative to the x-axis would be going up towards the upper right corner. So that's what I have in mind. I'm going to have things go at a 45-degree angle within this 600 by 600 drawing panel. And I've put some comments here about what I want to do. I want to draw an initial ball. How do we draw a ball? Well, we talk to the graphics object. We could do draw rect, but I don't want just an outline. I'm going to do fill rect because I want a solid black ball, a little solid black ball. Where is its upper left? Well, we'll have to think about that. But I want a little, it sounds like a lot, 10, but it turns out there's going to be a little dot on the screen. 10 pixels by 10 pixels isn't that big. So I'm making a little, not a rect, what am I saying? I wanted to do a fill oval. I'm sure you guys were recognizing that was wrong. I want a circle. I want a little dot, that's 10 wide and 10 tall. So how would I put it, where would I put it so that it would be centered? Well, remember that the drawing panel was 600 by 600, so you might imagine that this would be 300, 300, but that's not quite right, because remember that these are the coordinates of the upper left corner. And if we want this thing centered, in the very center, we're going to have to kind of scooch it a little to the left and a little bit up. We kind of want, it's going to be 10 by 10, so we kind of want to move half of that 10 to the left and half of that 10 up. So we really want an x-coordinate of 295 and a y-coordinate of 295 is where we want to draw that initial ball. Let me compile and run it and just kind of show you what I had in mind. So here's our 600 by 600, and there's our little dot, that's being drawn there at the center. And as I said, I want us to write a program that's going to kind of simulate having this ball be shot off in this direction. I want it to go at a 45-degree angle, although we want to be able to change the angle for a certain number of seconds at a certain velocity. So we're doing a little simulation of having this thing kind of going off in that direction. So, okay, what else do we need to do? So we're going to do an animation here. We're going to draw a series of frames. That's why I'm using the sleep command here. I'm going to be drawing this ball as it moves to the different positions. And so I'm going to have to keep track of where the ball is. So I'm going to have a double variable x that's going to start at 300.0, and a double variable y that starts at 300.0. We start at the center. So this really is, this is keeping track of the center of the ball. I'm going to keep track of that it's at 300, 300. And what do I do when I want to go to draw the next thing? Well, the ball's moving, so that means that there's some kind of a velocity in the x direction and a velocity in the y direction. So I'm going to want to update x to add in what I'm going to call x velocity. And I'm going to set y to be y plus y velocity. So I'm going to kind of come up with, change the xy, move it, scooch it, by a certain velocity, and then we draw a new dot. The dot, well, we can go ahead and draw the new dot. So what are we going to do? We're going to do a G dot fill oval like we did before with something, something, and 10 by 10. So we're going to draw the same size dot as we did before. And you might think that this would be x and this would be y, but again, it's that same issue. The xy I'm thinking of are keeping track of the center of the dot, and we've got to give the upper left coordinate. So it's not quite, it's the same kind of trick we did before where we would subtract 5 from this and we would subtract 5 from this. So we'll compute the new xy position, and then draw a new oval. That's kind of what we're going to do inside of our loop here. And then we do a sleep. That just slows it down enough that the eye can perceive it, so we can see what's happening. All right, so we got to figure those things out. We got to figure out, what is the x velocity? It's going to be equal to something. And what is the y velocity equal to, something. So we got to compute those. So this would be, where I'd ask people, try to remember things about your physics class, or anybody in the class taking physics, would if we've got something that's at a certain angle, how do we compute the horizontal component of the velocity versus the vertical component of the velocity? And we'd have some helpful student who would tell us that the math class is really helpful for this, that we want the cosine and the sine. That helps us to figure this out. So I can say that to get the horizontal component, I'm going to take the velocity and multiply by the cosine of the angle. And in order to get the vertical component, I'm going to take the velocity and multiply by the sine of the angle. So I use cosine and sine to get the subcomponents, kind of breaking it down into the x and the y. Those are my different velocities, how much it's moving each time. I use it to update xy and draw a new dot. Let's try compiling, and we get an error message when we try to compile. Incompatible types, possible lossy conversion from double to int. Well, here's what's going on. You might have a situation, say, where x had been computed to be, 715.321, something like that. Well, pixels in java.awt have to be specified with integer positions. You have to give it an int, because there aren't partial pixels. They're only complete pixels. So you're not allowed to give it a 0.321. You'd have to kind of turn that into 715, kind of chop off what comes after the decimal point. Maybe rounding would be a good idea, but chopping off is good enough. And chopping off is exactly what a cast does. So this is another place we're going to use a cast. We'll just kind of chop off that value. Let me mention briefly, there is an alternative, and sometimes some people will ask me about this. Why don't we just do all of our computations in int? Why be doing all of this? Well, we really want to track the XY location as accurately as possible. So double allows us to figure out exactly where that X and that Y are, but we turn it into an int when we need to turn it into an int. So, we're keeping track of that XY position, and we want it to be as exact as possible, so we use double to get, the good accuracy. But when we go to draw on a specific pixel, Java makes us chop off the decimal part with a cast. So that's kind of the right way to do it, is to do the computations in double, but to do the call on the fill oval, to give that the more specific coordinates. So let me repeat what this thing is supposed to do. That dot in the center of the thing is supposed to be moving in a 45-degree angle at a velocity of 38.4 pixels per second. So let's watch it do that. So it's going to go up towards here. It didn't do quite what I wanted it to do. So remember, I'm thinking of this relative to the x-axis. This is like the normal origin of a Cartesian plane. And 45-degree angle should be going like this, up to this corner. And it's not. It's going down, and it's not going down to a corner. I mean, it's kind of multiple things that are wrong here. So, we could kind of complain to our physics friends, who told us to use math.cosine and math.sine. It's not working. It's not giving us the right answer. Why isn't it giving us the right answer? Well, maybe we should have read more carefully what it says over here. Sine, cosine, tangent of angle in radians. Not in degrees, in radians. You thought you never had to deal with radians ever again, after taking that math class where they dealt with that. So that means that the computation we're doing here, this is the wrong angle, because we're doing 45 radians when we wanted 45 degrees. We got to convert from from degrees into radians. That's going to be a pain. We have to remember things about pi and so forth, and we do have a math.pi, constant. Still going to be a pain, except there's something called math.2radians that converts. It's like our 2 days method. It does a conversion for us. So that's very convenient. So let me go ahead and end this, and let me come back over here. And so instead of angle, I'm going to say math.2radians of angle. So I'm going to convert that angle in degrees into an angle in radians. Math.2radians, that angle. So now we're going to see it doing our 45-degree angle. So let's do a compile and execution, and we'll see it go to that upper right corner. There it went to the upper right corner. It didn't go to the upper right corner. Well, what's wrong now? Well, what's wrong now is, it is going to a corner. I guess that's the good news. The thing is, remember the coordinate math, y goes in the opposite direction. So there was something we didn't account for here. If we want, the Cartesian math, if we want, a bigger y to be going up and not down, we have to negate. So that's going to be a little bit better when we do it that way. Now, finally, we're going to get our 45-degree angle. What I think isn't quite right now, look, it's going at a velocity of 38.4 pixels per second. Well, how far is it traveling? This is 300. So it's traveling, 300 times the square root of 2. It's traveling over 400 pixels, and it's supposed to be at a velocity of 38.4 pixels per second. So it should be taking something like 10 seconds, to travel. So if we could count, we'll say 1,001, 1,000. We didn't even get to 2. it's not taking 10 seconds. Well, I did something tricky on purpose, which is that I wanted to draw a lot more balls than just one every second. So I'm kind of pausing every 10th of a second, every 100 milliseconds. And so I don't really want to I'm adding a full second's worth when I really wanted to add only a 10th of a second's worth. So this is going to kind of be going at the right speed. So now we'll see kind of that black ball moving in that direction. I want to make one more little change to this, which is that before I draw the next frame, what I'm going to want to do is I'm going to say g.setColor to be color.white, and I'm going to copy this line of code right here. I'm going to erase the previous dot. Erase. I'm going to turn it white. I basically want to see where we've been as a series of little white balls and where we're headed to be a series of black balls. And that's almost what I wanted to do. How come they're all white? Well, even the new one? Well, because I changed it to white here, but then I didn't change it here. Before I go to draw that oval, I have to do a set color to be color.black. Oops, set color to color.black. So I'm erasing kind of the old ball by painting over it with white and then painting the new one in black. That was kind of the program I intended for us to have. We see something going off at a 45-degree angle, showing us where it's been and where it is right now. There's that ball kind of traveling off at 45 degrees. All right, I'm a little bit over, so I'm going to go ahead and end there. We'll do more with this example next week.